Hey everyone, this is lesson 6-2, Multiplying Polynomials. This is part of Unit 6, which is talking about just polynomials in general and the operations that go along with them. So we've looked at how to name polynomials and some of the vocabulary that goes along with that, the degree and the number of terms and the leading coefficient. And today we're going to look at how to multiply two polynomials together. So we have actually done this already. This is just the distributive property, and so we need to multiply, everything in the first expression by everything in the second expression, or everything in the first polynomial by everything in the second polynomial, and that's generally what we're going to be doing. So there's a couple of different methods I'll show you. So let's get going. So first of all, just a quick review of the distributive property, right? We've done this before, and hopefully you're pretty proficient with it. When we have a number here, right, or something multiplied by a polynomial expression. So this polynomial expression is x plus 1. And so this is a linear binomial, right, multiplied by a constant monomial, right? We want to use that vocabulary, use that terminology. But all we're going to do is we're just going to multiply everything in this by everything in this. There's only one thing in here, so we're going to multiply 3 times x. We're going to multiply 3 times 1. And so when we multiply 3 times x, we get 3x. When we multiply 3 times 1, we get 3. Okay, so pretty straightforward. Same thing here. We're going to multiply this 2 times the 4x, multiply the 2 times the negative 2, and so we would get, we're going to get 8x minus 4. And, now we have, on this example, we have a variable on the first part, right? So this is a linear monomial and a linear binomial. And let's see, when we multiply these together, we do the same thing. We multiply 2x times x. And since we're multiplying those x's together, we get an x squared, x to the second power, and then the x times 5 gives us 5x. Okay, so that same principle, we're going to expand on that. Now, the challenge in doing this distribution when we get larger polynomials is mostly just about keeping track of what we're doing. It's about kind of like making sure that we write it all down, that we kind of keep track of what multiplications we've done, and that we combine our like terms and that sort of thing. So I'm going to talk a little bit, before we get to that, we want to talk a little bit about just multiplication in general. Okay. Now, most people, have seen this algorithm, right? This would be kind of a vertical form of multiplication. And so we multiply 3 times 2, we get 6. And we multiply 3 times 1, we get 3. We come down here, we put a placeholder, right? Because now we're multiplying the tens number. So we put a placeholder in the 1 spot. 1 times 2 is 2. 1 times 1 is 1. We add those together, we get 156. Okay. Now that's one way of doing that, and that's kind of the standard sort of algorithm, or the standard sort of method that people use. What gets lost in this is, what we're actually doing. We're multiplying the 3 times the 2. This is 3 times 2. These are in the ones position. When we multiply 3 times this 1 here, this is not 3 times 1. It's actually 3 times 10. So this is 3 times 10. So this is 30 plus 6 is where we get the 36 from. And likewise, when we multiply the 1 here, this is not 1 times 2, it's 10 times 2. So we put that 2 in the tens place. And so this is 20. And then when we multiply the 1 times the 1, this is 10 times 10. This is 100. And so we put that in the hundreds place. Now, another way to do this, and some of you may have seen this, it's not, I don't know how standard it is, but it's certainly a way that you can do this. And this is called an area model. Okay. And so what I'm going to do is I'm going to rewrite 12 as 10 plus 2. So I'm going to break out the tens and the ones. And likewise, I'm going to write 13 here as 10 plus 3. Okay. And then when I go through and do this, what I'm going to do is I'm basically going to treat this as a multiplication table. And I'm going to fill this out. I'm going to multiply this number times this number times this number, the 3 times this, and the 3 times that. And so when I go through that, 10 times 10 is 100. 10 times 2 is 20. 3 times 10 is 30. And 3 times 2 is 6. And then I can just simply add those together. So this is 100, 20 plus 30 is 50, and 6 is 6. So that's 156. So we just add all those together. All right. Now, different approach to it, but the advantage of this, right, is that you don't lose that meaning of those numbers. So I recognize that I'm multiplying 10 times 10 and I get 100, which is this number right here. I multiply 10 times 2, which is 20, which is this number right here. I multiply 3 times 10 is 30 is this number here, and 3 times 2 is 6. So I'm maintaining the fact that those are the actual numbers, and they're not just, you know, 1s and 2s and 3s. So this is called an area model. We can do the distributive property using an area model. So, for example, if I wanted to multiply these things together, right, these two binomials together, so I've got a linear binomial and a linear binomial, I can do this the same way. I can just simply write this binomial right up here. This is x plus 4, and this is 2x plus 5. And then I can just do the same thing. I can just fill out this table of values here, right? I can just do this multiplication table. So I get 2x times x gives me 2x squared. 2x times 4 gives me 8x. 5 times x gives me 5x. And 5 times 4 gives me 20. And then I'll do the same thing. I'll just add these together. Now, the difference here is that I can't add all of these things together because they're not all like terms. Just like I couldn't combine them up here, right? I can't combine them all here, but I do have some like terms. And in this case, those like terms happen along this diagonal here. So I got a 5x and an 8x. And so I can write this out. My answer is going to be 2x squared. And then if I add 5x and 8x, I get 13x. And then 4 times 5 gives me 20. So that's another way of doing that. Notice I'm multiplying every part of the first polynomial with every part of the second polynomial. So I've multiplied x times 2x, I've multiplied x times 5, I've multiplied 4 times 2x, I've multiplied 4 times 5. I've done those 4 multiplications there. And notice that, you know, I have a multiplication for every term that's in there. So I've got a total of 4 terms that are being multiplied together. I've got 4 multiplications that I have to do. So again, it's more of it's kind of a bookkeeping way of doing it. It's a way of saying, okay, I need to do 4 multiplications, and I can write down what each of those multiplications are, and then I can go back and add those together. Okay, so that's an area model. So another way of doing this is what's called the FOIL method. And what I don't like about the FOIL method is that it only works when you have 2 binomials. Okay, when you have 2 binomials. It doesn't really apply when you have like a binomial times a trinomial, for example. Whereas an area model, you can do that. But what this stands for is FOIL stands for first, outside, inside, last. So that's what that means. But really, it's just another way of sort of keeping track of what we have to multiply together. Okay, so first, the F means multiply the first ones together. That's this one times this one, right? So we can draw that. Oops. My software's taking a break here. Hopefully it doesn't crash. There we go. So I multiply 4 times 2x, right? 4 times 2x. That gives me 2x squared. And then I'm going to multiply the outside ones. So the ones on the outside, the x and the 5, that gives me 5x. I'm going to multiply the inside ones here. 4 and 2x is going to give me 8x. And then the last ones, right? The last ones in each one of those binomials, the constants, 4 times 5 gives me 20. And again, I can just simplify that and add my like terms. Again, my software's taking a break here. There we go, 20. That's kind of a funny too, but so we end up with the same thing, 2x squared plus 13x plus 20. Okay. So two different methods of doing that. So when I was learning this, my teacher talked about Mr. Foyle, and so he said that when you do this, it kind of looks like a face, and so like here's his ears, right, and this I guess is his nose and his mouth, and this is maybe his hair or his eyebrows or something. Anyway, so he would always say, well, you put some eyes in there, maybe he's got some glasses, maybe that's his nose, and you can make a happy face out of it. You add some hair. So they call him Mr. Foyle. I see right now that's kind of sexist. It should be Mr. Foyle or Miss Foyle, or gender doesn't make any difference. Anyway. Anyway, so that was the way that I kind of remembered it. I always remembered Mr. Foyle and having to draw that face. So, all right, let's take a look at some examples here. So we're just going to multiply these together, and I'm going to use some of the different methods here to do this. So I'm gonna FOIL this first one, and so I'll do w times w gives me w squared. Okay, my software is just throwing a fit there. I'm going to multiply the outside ones here, so I get 5w. Multiply the inside ones here, I get negative w. Watch your signs here. This is negative 1 times w. And then negative 1 times positive 5 gives me negative 5. And when I combine my like terms, I get w squared plus 4w minus 5. Okay, so there's the first example. The second example here, I'm gonna go ahead and use an area model just for fun. Let's see how this compares. So here I've got x plus 2, and here I've got x and minus 2. And so I'm going to multiply these together, fill out this form here. So I've got x squared, I've got negative 2x here. X times 2 gives me positive 2x. Positive 2x, and then negative 4. And I'll go ahead and combine my like terms here, and I'll see that I've got like terms here and here, right? And when I combine those actually cancel out. So 2x minus 2x gives me 0. So all I'm left with is the first term and the last term. So I get x squared minus 4. Okay. Notice what happened there. We're going to take a closer look at some of these moving forward. But here I've got these polynomials, right? These two binomials are really similar. The only difference is that one of them has a negative 2 and one of them has a positive 2. The numbers are the same. The signs on the second number are different. But look what happens when we multiply that middle term, right? That middle term, those middle terms cancel each other out. Okay, so an interesting thing there. Here's another example, x plus 4 squared. Okay, now, a lot of people misinterpret this. Okay, this doesn't mean x to the fourth, x to the second square to the second power and 4 to the second power. It means x plus 4 times x plus 4. All right, so we want to be really careful about that. That's a really common misunderstanding that people have. This does not mean we just take the second power and apply that. It means x plus 4 times itself. So we're going to have to, I'll go ahead and FOIL this out here. So I've got x squared. I've got my outside ones. I've got 4x. My inside ones, I've also got 4x. Notice that those are the same. right? Another kind of interesting thing to look at. And then we've got 4 times 4, which is 4 squared, which is 16. And so we get x squared plus 8x plus 16. Okay, notice again, this is one of those kind of special patterns that we're going to look at when I have this squared. What I end up with in the middle is this number times this number times 2. So I have 2 of these 4 times x's, and so I get 8x. And so again, it's an interesting kind of pattern that we'll try to take advantage of as we go forward. Here I have an example where I have some different variables together. Okay, I've got an x and a y both in there. Doesn't matter, right? We're going to do the same process here. And so I'll do my area model on this one. And so I've got x and then plus y, and then I've got 2x and negative y. And so multiply these together, I get 2x squared. I multiply x times negative y, I get negative xy. 2x times positive y gives me positive 2xy, and y times negative y gives me negative y squared. So again, I'll look to combine my like terms, so I have like terms here and here on the diagonals, and so I get 2x squared. 2xy minus xy gives me just 1xy, and it's positive 1xy, and then minus y squared. Okay, and the very last one, so here we have a binomial times a trinomial. Okay, so 2 times 3. So the FOIL, right, that acronym FOIL doesn't really apply here, but we can do the same thing. We can take this x and multiply it by every one of these, and then take this 3 and multiply it by every one of these. Okay, we can also do this as an area model. Instead of a 2 by 2 grid, we'll have a 3 by 2 grid, right? And so we can do it the same way. So I'm going to go ahead and do an area model here just to show. So this is x plus 3. Work here. And across here, I'm going to put 2x squared minus 3x plus 1. Okay. Now, I chose to put this along the top. I could have, flipped that and written it down along the other side. I also wrote these out in the order that they are, their standard form. I can write them in any order I want to, just as long as I keep those signs with the numbers, and as long as at the end I do a good job of combining my like terms. Okay, so I don't need to put them in this specific order. It doesn't really matter. So I'll go ahead and multiply these together. So I get 2x cubed by negative 3x. My software, it's just not having it today. It's been early. Minus 3x squared plus x, and then I've got 6x squared, and then I've got negative 9x and positive 3. Okay, so now I still need to combine these, right? Add these all together. I've got like terms. I've got like terms here and here, right, on those diagonals. And I've also got another set of like terms here and here. So the x's, right, and then I've got the x squareds. Okay, so I'm going to type this out because my software is kind of messing up a little bit, but I get 2x to the third power plus, and then I've got 6x squared minus 3x squared. That gives me 3x to the second power. And then I've got negative 9x plus x. That gives me negative 8x. And then I've got a positive 3 at the end. So plus 3. Okay. Now, again, I could do this using the distributive property. I could multiply this times this, multiply this times this, multiply this times this, and then I could take the 3 and multiply it by each one of these. Right? times that, and that times that. Okay. So I would still get the same thing. I'm still doing the same multiplications. I'm multiplying x by 2x squared, which is what I did here. I'm multiplying x times negative 3x. I'm multiplying x times 1. Right? That process, the multiplications we do are the same. We combine like terms the same. It's just a different way of kind of working that problem. Right? Now, the challenge will be, how do you multiply 3 polynomials together? How do you multiply 3 polynomials together? Okay, and the answer is you don't. The answer is you multiply the first 2 polynomials together, and then you take that result and you multiply it by the third one. So you have to go through a number of multiplications there in order to get those. So so you'll see a problem like that in your homework. So take a look at that, and if we need to work that in class, we can do that. All right, I'm going to go ahead and end the recording here. Please let me know if you have any questions.